Right, so there's 4 things that you need to consider in order to draw a graph. So the first one is to consider the limit as x approaches infinity of the function and the limit as x approaches negative infinity of the function. The second one is you need to consider the limit as x approaches any other asymptotes. The third one is to find the x and y intercepts. And you do that exactly the same way that you've always done. Just make x equals 0, solve for y, make y equals 0, solve for x. Yes? And the fourth one is to find the stationary points. And you have to decide whether they're a local min, a local max, or inflection, point of inflection. Right, so our example. So y equals x squared plus 3 over x plus 1. Okay, so number 1, we have to consider the limit as x approaches infinity and x approaches negative infinity. So what happens when we substitute x for infinity into that fraction? We just get infinity over infinity. So it doesn't actually tell us much about the function. So we need to go ahead and divide them. So with polynomial division. Now, you can do this on your calculator. Do you want to practice it now, though, by hand?
Are you doing the test?
We've got your calculator in the test, so just do it by calculator. Right. So what we get is, by division, we get f of x equals, got it written down here somewhere, x minus 1 plus 4 on x plus 1. Right, so the limit as x approaches infinity for the function, substitute infinity for this term here, what do we get? Four over what?
This side? This way we got that.
Sorry? That was, I divided this.
Why?
Divided x squared plus 3 by x plus 1. Because we said if we just try to find the limit as x approaches infinity, what we get is infinity over infinity. So it doesn't actually tell us anything about where the line is approaching. We just get as x approaches infinity, y approaches infinity, but we're not actually seeing like where it's going on the graph. We're just seeing as x gets bigger, y gets bigger. But it could be going in any like direction. It'll make sense in the end, I promise. Right, so we divided them by polynomial division. So we got this second term here. So what happens if we put x equals infinity into the bottom of this fraction? get 4 over a really, really large number, so, which is a really small number, right? Right. Small number. So what we see is that because a fraction is so infinitely small, it's basically like we can discard it, and we can say that the limit approaches this one here. So as x approaches infinity, the function approaches x minus 1. And the limit as x approaches negative infinity, what happens again when we put negative infinity into this function here? Same thing. It's just like taking away a really, really small fraction. So it's still, we can still discard it and say that the function approaches x minus 1. So that's the first step done. What we see as x is getting bigger, the function approaches y equals x minus 1, the line, a straight line, like approaches that. And as x approaches negative infinity, as it gets more and more negative, it still approaches that y equals x minus 1 line. Okay?
So what part do we do on the calculator?
Just the polynomial division, dividing those. Dividing the top term by the bottom term. Right? Okay, step number 2. So, looking at the question, are there any other asymptotes, a number that x cannot be? Yeah, negative 1. Because otherwise you get a 0 on the bottom of the fraction. And it's also written like right here. Right there, it just tells you straight away that x can't be negative 1. So now we need to find the limit as x approaches negative 1 from the positive side for the function. Remember, because x equals negative 1, we can either approach from this side or we can approach from that side. So what we're going to do is substitute in values into the original function here that are getting closer and closer to negative 1, but from the positive side. So that would be like sub in x equals negative 1 from the positive side would be negative 0.5, like negative 0.7, negative 0.9, you can go negative 0.99, negative 0.999, and keep going closer and closer to negative 1 from the positive side and see what happens to the function. So grab your calculators out and then sub in these numbers into this fraction here and then see what happens to your answer. So like as we approach negative 1 from the positive side, our function is getting larger and larger, so we can say that it approaches infinity. Now we need to find the limit as x approaches negative 1 but from the negative side. So we'd sub x equals negative 1.1, negative 1.01, negative 1.001, negative 1.0001. Do that, see what happens. Negative infinity, yeah. There we go. So as we approach the line x equals negative 1, your y value is getting exponentially larger up to infinity and then down to negative infinity. Okay, number 3. We need to find the x and y intercepts. So make x equals 0. We get f of x equals 0 squared plus 3 over 0 plus 1, which is obviously 3. So our y-intercept is 3. And then we make a y equals 0. Oh, not f of x. 0 equals x squared plus 3 over x plus 1. Right, how do we rearrange? You don't need to do the calculator. Just take this over and multiply it. Multiply it by 0, you get 0. So x squared plus 3 equals 0. Take the 3 over. X squared equals negative 3. X equals plus or minus the square root of negative 3. Does that number exist? No. So no x-intercepts. The line will not cross the x-axis. Okay, number 4, we need to find the stationary points. How do you find stationary points of a function? Derivative equals 0, yes. So we had our function here. Now, you could do this by hand using what rule?
The
Quotient rule. Because they're not being multiplied by each other, being divided. Yep. Well, of course, you've got your calculator, so you can do it on the calculator. We get x squared plus 2x minus 3 over x plus 1 squared. So that's our derivative there. Now, of course, to find stationary points, we make that equal 0. So x squared plus 2x minus 3 over x plus 1 squared equals 0. Multiply over the denominator. Can we factor that into 2 brackets? No?
Yeah.
3 and 1? Yeah, you can. If not, use the quadratic formula or try to complete the square.
If you just left it as that, is that okay?
Left it as what?
X squared plus 2x minus 3.
Yeah, but how are you going to find x?
Oh, you find the x.
We're looking for the coordinates of the stationary points. So we need to solve for x and then solve for y. So we get x equals negative 3 and x equals 1. Now, of course, you need to solve for the y coordinates. So, sub it in. So y equals negative 3 squared plus 3 over negative 3 plus 1, which is 9 plus 3, 12 over negative 2, that's negative 6. So we've got the point negative 3, negative 6. And we've also got 1 squared plus 3 over 1 plus 1, which is 4 over 2, which is 2. So we've got 1, 2. Now, you need to test if they're local max, local min, or stationary point of inflection. So what do we need to do? Yeah, find something either side of the x value. So we'll test negative 4. So what do we get? Negative 4, so that's 16.
Is the derivative or the original?
Oh, sorry, derivative, yep. Sorry. We get 16 plus, minus 8 minus 3 over 5 squared, 25. No, sorry, negative 4 plus 1 is negative 3, squared is 9. 16 minus 8 minus 3, we get 8, 5 on 9. So it's a plus. Remember, we don't actually need to know the value of it. We just need to know whether it's a positive or a negative. So it's a positive. We can test -2. Would we test -1? Why not? It's an asymptote. Yeah, if you tested -1 on here, you'd get a 0 on the bottom, which wouldn't tell you anything. Okay? It's -2. We'll get 4 minus 4 minus 3, which is -3. And this number on the bottom is always squared, so that's always going to be positive. So that tells us it's a negative because we had a -3 on top. And then for this one, we can test 0. So 0 plus 0 minus 3 over a positive number is a negative number. And 2. So 4 plus 4 minus 3, that's going to be positive. So what we get here is a positive, and then our point, and then a negative. And here we get a negative, and then our point, and then a positive. So this one's a local max, this one's a local min.
Before you go further, when you get the derivative,
Yep.
if you use, hey, you got x squared plus 2x plus 3.
This bit?
Yeah.
Oh, that was just on the calculator.
Oh, so you didn't actually work anything out?
No, I didn't work anything out. Just did it on the calculator. The quotient rule's long.
Yeah, okay, I thought you did. Okay.
Simplifying everything takes a while, so I just did calculator. Nah.
Yeah, I looked at it for a while. No, I just didn't know what was going on.
Yeah, no, just calculator.
I missed another question.
Yeah.
How come sometimes we tested 3?
Because we had 0. We've got an asymptote at -1, and we've got our point -3, -6 here, and 1, 2 up here. I originally just tested 0 because 0 is between the 2 points, but then Matt said, like, what happens because it might be a different gradient on either side of the asymptote, and I was like, yeah, good point. So I tested like this number here, and this number here, and then this number here, and this number here. Yeah, so that's why I tested 4. Okay, so let's go back to what we've got. So we had as x approaches infinity, the function approached x minus 1, and negative infinity also approached x minus 1. From step 2, we had as x approaches -1 from the positive side, we got infinity, and -1 from the negative side, we got negative infinity. We had a y-intercept of 3, no x-intercepts. And we also had stationary points at -3, -6, which is a max, and 1, 2, which was a min. We know from our working out that asymptotes are x equals -1 and y equals x minus 1, which is from the first step. So we can draw it up. We'll try and draw it as straight as possible. Not very straight, but you get the idea. Okay. Of course, you should use a ruler when you're doing this. Don't do it freehand. Right, so our asymptotes are x equals -1. So that is a line going down here. And y equals x minus 1. So it's got a gradient of 1, but it's moved one space down. So it goes roughly through here. Yep. So those are our two asymptotes. So the lines should neither touch nor cross those two asymptotes. This is x minus 1, and this is x equals -1.
So you know -1 that
Because from the very first part of the question, it said the domain is all of r except for -1. Or, you know, you look at the fraction and it's x plus 1, so x can't be a -1 or you get a 0.
Yep.
Yeah.
Yep.
And that was in step 2, we tested that asymptote, the limits. Yeah. Okay, so we've got our stationary points at 1, 2, so roughly here, and at -3, -6, so roughly here. -6. We know that as x approaches -1 from the positive side, so that's up the top here, so as we're getting closer and closer to this asymptote, we're approaching infinity. So yeah, we'll go through 3, so that's our y-intercept. So we're approaching -1 from the positive side and getting up to infinity. We know as we approach -1 from the negative side, we're going down to -infinity. So it's going down that way. As x approaches infinity, so x is going up to the right, we're approaching the x minus 1 line. And as x is getting more and more negative, we're approaching that same asymptote. Right, that last little bit that we did. So if you look at the working out that we did for part 1, what we got was x minus 1 plus 4 on x plus 1. So like what happens if you substitute x equals infinity into that fraction? We got plus a really, really small decimal. So what we're getting is like as x approaches infinity, we're getting this line plus a really, really small amount. That is why the line is on top, because it's this line plus a little bit extra, a tiny bit extra. And then we said as negative infinity, you'd be minusing a tiny little bit. So as we're going down this way, it's the line x minus 1, but minus a tiny little bit. That's it. That's all. The line is drawn.
Can we do another example?